let's just start from the beginning. I'm going to actually break this video, or these videos up, this review up into multiple videos, so it'll be easier to just get to certain problems, okay? The first video is going to be over, I guess, just page 1. Yeah, I'll do that, and then we'll go from there. Okay, so number 1 says the square root of 0.49. Well, so what I always want you guys to do is to rewrite that as a fraction. The square root of 0.49 is the square root of, let's get making it kind of dark, or really light. Let's see. There we go. Okay. So you take the whole number, like take away the 0, take away the decimal, and you got 49. And then if you want to rewrite that as a fraction, you say 49 divided by tenths, hundredths, so 100. Or you can say I moved over 2 places, so that's 2 zeros. Okay? And the square root of 49 is because I've got the square root of a fraction. I can take the square root of the top and the square root of the bottom. The square root of 49 is 7, and the square root of 100 is 10. And since we started with the decimal, we're going to end with a decimal. So you know how 49 over 100 was actually 0.49, so there were 2 zeros. It went this way too. There's only 1 0, so it's 7.0, and then you move it 1 place, it's 0.7. Or just knowing that 7/10 is 0.7. Alright, number 2, sorry. Number 2 is the cubed root of 0.125. So I want you to do the cubed root of 125, so take away the decimal and 0, and then tenths, hundredths, thousandths, divide it by 1,000, and then you can break it up. The cubed root of 125 is 5, and the cubed root of 1,000 is 10. And so 5 over 10 is 0.5. And I'm getting those numbers, the cubed root, because if you look at your powers of 3, not your powers of 3, these, but numbers being raised to the third power. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, which means the cubed root of 125 is 5. Okay? So, the fourth root of 0.0016, that means we take the fourth root of 16, so take away the decimal and the zeros, and then tenths, hundredths, thousandths, 10,000ths, which means you divide it by 10,000, and then we take the fourth root. So my power chart says that 2 to the fourth is 16, which means the fourth root of 16 is 2. So that's a 2. And then the fourth root of 10,000 is 10. And that translates to 0.2. Okay. Number 4 is the fourth root of 6,561 divided by 625. So I look at my power chart and I go across the powers of 4. So 6,561 is right here. And I see that 9 to the fourth is that, which means the fourth root of 6,561 is 9. So that is 9 divided by, and then the fourth root of 625, 5 to the fourth is 625, which means the fourth root of 625 is 5. And since we start with a fraction, we can end with a fraction. And there you go. Number 5 says, well, the directions say simplify each radical expression. So what I want you to do is I want you to take everything out of a root that you can. When you talk about the square root of 72, 72 is not a perfect square, but when I look at my powers of 2, so 4, 9, 16, 25, 36, 49, 64, and 81, 72 lands in between these two, and so I know that 64 does not divide into it evenly. I know 49 does not divide into it evenly, but 36 actually does twice. Okay. So that's actually 36 times 2. And the square root of 36 is 6, which is why there's going to be a 6 on the outside and a 2 left on the inside. Okay? And then there's an understood 2 right here. So whenever we're doing the square root, or when we do a root of a variable raised to a power, you really should just be asking yourself, how many times does 2 go into 2, right? 2 goes into 2 one time, and that makes sense because if I'm taking the square root of x squared, they should just cancel each other out, leaving me with x to the first. Or you can think of it as the square root of x squared is x to the power over root 2 over 2, which is just x to the first. So I'm just making sure you understand why we do that, okay? 2 goes into 2 one time with none left over. 2 goes into 5 twice with 1 left over, and 2 goes into 3 once with 1 left over. And so your answer should be 6x y squared z times the square root of 2yz. Number 6 is the cubed root. So 32, I can look at a couple different ways. When I'm taking the cubed root, I'm looking at powers of 3, and I see that 2 cubed is 8, and that 3 cubed is 27, so 32 lands in between here. 27 does not divide into evenly, 8 does. Or I can look at 2 cubed as 30, or as 32 is 2 to the 5th. So a couple different ways to do that. I could think, well, I'm taking the cubed root of 32, which is 8 times 4, and the cubed root of 8 is 2, and I can't take the cubed root of 4, so the 4 stays inside. Or I can think of it as the cubed root of 2 to the 5th, which is 32. 3 goes into 5 one time, so 2 to the 1st with 2 left over, and 2 squared is 4. Okay? So a couple different ways to think about that. So either way, I've got a 2 on the exterior and a 4 left on the interior. 3 goes into 12 4 times evenly with none left over. 3 does not go into 2, so y squared is just left inside. And 3 goes into 9 3 times with none left over, and so that's my answer. 2x to the 4th z cubed times the cubed root of 4y squared. I noticed that a lot of people on the homework were forgetting to write that root. You need to make sure that it's the cubed root here versus the 6th root there versus the 4th root there. So just be careful about that on your answer. All right, number 7, 324, 4th root. So, I forgot this lighting. As far as 4th roots go, 324 is not on the list. We've got 16, 81, 256, and 625. 324 is in between them, right? 256 does not divide into it. But if I think about 81, 8 times 4 is 32, and 1 times 4 is 4. So that is 81 times 4. And I know that the 4th root of 81 is 3. So that means I'm going to have a 3 on the exterior. And then inside the 4th root, I'm going to have a 4 left over. Because the 4th root of 81 is 3, and then there is no 4th root of 4. Okay? Then I just go with the variables. 4 goes into 13. 4 times 3 is 12. So it goes into it 3 times with 1 left over. You don't have to put the power 1, but sometimes it helps to just see it. 4 goes into 6 1 time with 2 left over, and 4 goes into 18. 4 times 4 is 16, so 4 times with 2 left over. And there you go. Number 8 says the 6th root of 1,458, and then all of those variables, so let's go with powers of 6. So, 64, 729, 4,096. Okay, 4,096 is too large. 1458 is in between here. So I've either got 729 or 64. And when I look at 7 times 2 is 14, and 29 times 2 is 58. So that is, in fact, 729 times 2. Okay? Sorry. I need to look at that real quick. The 6th root of 729 is 3. So that I can simplify as a 3 on the exterior and the 6th root of 2 on the interior. Okay, 6 goes into 40, 6 times 6, so that is 6 times is 36 with 4 left over. 6 goes into 18 3 times evenly, so none left over. 6 goes into 11 1 time with 5 left over. And 6 goes into 27. 6 times 4 is 24, so 4 times with 3 left over. Alright, and don't forget, that's the 6th root, so if you don't have that labeled, it makes it kind of wrong. Not kind of wrong, it makes it wrong. Alright, number 9. Number 9 says multiply 4x squared times 2 times the square root of 9x squared y squared. There are a couple different ways to approach this. I'm going to work it out one way and then work it out another way, okay? So one is to just simplify them all together. 6 times 2 is 12, and then write the square root of 4 times 9 is 36. X squared times x squared is x to the 4th, and there's only y squared, and then go from there. So 12, the square root of 36 is actually 6. The square root of x to the 4th, well, 2 goes into 4 twice, and 2 goes into 2 once, which means my answer is 72 x squared y, because 12 times 6 is 72. I did see some people simplifying it separately. So they said, and this will work out sometimes. Sometimes it creates more work for yourself. This one, it's fine because everything works out. But, I mean, perfectly. I'll show you another one. Okay. So 6, the square root of 4 is 2. So this is just taking each of them and simplifying them by themselves. And the square root of x squared is x. Then times 2 times the square root of 9 is 3. The square root of x squared is x, and the square root of y squared is y. 2 goes into 2 once, 2 goes into 2 once. So you end up with 6 times 2 times 2 times 3. 6 times 2 is 12. 12 times 2 is 24. 24 times 3 is 72. X times x is x squared, and then y. Okay, so either way we get 72 x squared y. If you notice that these are all perfect squares, then go ahead. You know, if it simplifies, then I would go ahead and do that. But it might or might not. It kind of depends on the problem. Number 10. I've got 3 times the 4th root of 16x to the 11th y to the 7th times the 4th root of 625 x to the 5th y to the 11th. The first thing I'm going to do is look at 16 and 25 and see if they're perfect powers of 4. 2 to the 4th is 16, so that's promising, and 5 to the 4th is 625. So I kind of already know that I can simplify those two. I am, however, going to combine them, and then, but just not multiply them together. I mean, I'm going to write that they're multiplied, but I'm not actually going to multiply it out. So I'm going to write 16 times 625, and then I'm going to combine x to the 11th times x to the 5th is x to the 16th, so we add the powers. Y to the 7th times y to the 11th is y to the 18th. Okay, and I'll show you the other way that you might have solved it in a second. So we've got 3 times. Now the 4th root of 16 we said was 2, and the 4th root of 625 is 5. As far as the variables go, 4 goes into 16 4 times, but 4 only goes into 18 4 times with 2 left over. So we've got 3 times 2 times 5, so that's 6 times 5, that's 30. X to the 4th, y to the 4th times the 4th root of y squared. Alright? I had other people that worked it separately, so this is 3, and then the 4th root of 16 is 2, and then 4 goes into 11 twice. 4 times 2 is 8. So we said x squared, and then you had, let's see, 3 left over, so x to the 3rd. And then you had the 4th root of 7, so 4 goes into 7 one time with 3 left over again. And so that was that one. Times. The 4th root of 625 is 5. 4 goes into 5 one time with 1 left over. And 4 goes into 11 again twice. 4 times 2 is 8 with 3 left over. Okay, so the annoying thing about this is that now you've got to combine the stuff outside the square root and the stuff inside the square root, not the square root, the 4th root, and then simplify further if possible. So I've got 3 times 2, which is 6, times 5, which is 30. X squared times x is x cubed. Y times y squared is y cubed. And now I've got the 4th root of, I've got to combine these as well, x to the 4th and y to the 6th. So now I have to simplify again. 4 goes into 4 one time, which means I bring another x out. X to the 1st, which combines with this x to make 30x to the 4th. And then 4 goes into 6 one time. So I have to combine that and say y to the 4th, leaving me with 2 left over. It's not a wrong way to do it, it's just a little bit more complicated and a lot more work. So it's just whatever you see is what you do. Just make sure that you're prepared to do all the work associated with it, okay? All right. Number 11. Number 11, so I'm going to work it out with, well, so like I said, the way that I started number 10 was I looked at 16 and 25 to see if they were perfect fourth roots. 20 and 500 are definitely not perfect cubed roots. So I'm going to work it with multiplying it out, and I'm also going to work it with breaking it down into prime factors, okay? So I've got negative 2 times the cubed root of 20 times 500. Well, 2 times 500 is 1,000. So 20 times 500 is 10,000. Yes? Yes. And just to be sure so I don't look like an idiot. Okay. And then we combine the x's. X to the ninth and x to the fourth is x to the, add the powers, you get 13. Y to the 14 and y to the 12th, so that's 26. And then z to the 12th. So then I start simplifying. Okay. The cubed root of 10,000. Well, I know there's a cubed root of 1,000, which means 1,000 goes into it 10 times. Sorry, I was thinking about something else. So this is 1,000 times 10, which means the cubed root of 1,000 is 10, so I bring a 10 on the outside. I'm multiplying it times negative 2, so that's a negative 20. And then I'm left with a 10 on the interior. All right. Then I say, okay, 3 goes into 13. 3 goes into 13. 3 times 4 is 12, so 4 times with 1 left over. 3 goes into 26. Let's see. 3 times 8 is 24, so y to the 8th with 2 left over. And 3 goes into 12 4 times evenly, and so that should be the answer. Let me check it the other way. So the other way to do it is to multiply, or is to break it down. Negative 2 times the cubed root of 20 times 500, x to the 13th, y to the 26th, z to the 22nd. I thought it was a 14. 12. Okay. So 20 and 500. If we start breaking it down, I know that 20 is 2 times 10. And then I know that 10 is 2 times 5. 500 I know is, I mean, it's, however you see it. You could see it as 5 times 100. You could see it as 50 times 10. You could see it as 2 times 250, however you do, just break it down. Okay, so that's that 5. And then 100 is 10 times 10, which is 2 times 5 times 2 times 5. So altogether I have 1, 2, 3, 4 2s, so 2 to the 4th. And then I have 1, 2, 3, 4, 5, so 5 to the 4th. So I could see it as the the cubed root. The cubed root of 2 to the 4th, 5 to the 4th. So the cubed root of 2 to the 4th is, well, 3 goes into 4 one time, so I bring out 2 to the 1st with 1, 2 left over. And then 3 goes into 4 one time, so I bring out 5 to the 1st with 1 left over. So I am left with 10, and then times the cubed root of 10, which is what we got in the other one. Okay? And then I had a negative 2 out in the front, so that became negative 20. Okay, and then the variables are the same. So you can either break it down in prime factors if you don't have a calculator, or even if you don't have a calculator, you might be able to go ahead and just multiply out 20 times 500 and look at your power chart and see. Okay? The numbers are not going to be that large on the test without a calculator, but it's not like it's something you couldn't do. Number 12. Well, let's see. Yeah. Number 12 is the square root of 18 divided by the square root of 10. So there's a couple different ways to work this one as well, so I'll show you all the main ways, and then you can go from there, whichever one you like. So I think of the square root of 18 divided by the square root of 10 as, like, in my mind, it's underneath one root, right? So 18 divided by 10 simplifies down to, if you divide both of them by 2, 9 over 5. So I've got the square root of 9 divided by the square root of 5. Well, I know the square root of 9 is 3, and then I'm dividing by the square root of 5. But the point is, to remember, you have to rationalize. So I don't want to square root in the denominator. And I know that if I multiply by the square root of 5 on top and bottom, then I'm going to be left with 3 square roots of 5 divided by the square root of 5 times the square root of 5, which is not just gone. A lot of you are just like, it goes away. That's not true. The square root goes away because it's square root of 5 times square root of 5, which is just 5. So my final answer is 3 square roots of 5 over 5. I've seen some other ways, though. I had some people that went ahead and just multiplied by the square root of 10 on top and bottom. I would, simplify as much as possible. 9 times 2, so the square root of 9 is 3. So I've got 3 square roots of 2 divided by the square root of 10, and then they multiply top and bottom by square root of 10. So that is 3 square roots of 20 divided by 10. But then you got to think, okay, 20 is a perfect square. It's 4 times 5. My paper. Which means I can simplify out of 2, so that's 2 square roots of 5. And then, so that's 2 times 3, that's 6 square roots of 5 divided by 10. And then 6 and 10 both divided by 2, that makes it 3 and 5. You get to the same answer, but it's a lot more work. Always simplify vertically if you can, okay? Simplify the coefficients to make sure life a whole lot easier. On 13, like I said, simplify vertically. So 9 and 18, they both divide by 9, so that's a 1 and that's a 2. And then x's, I see 4 of those canceling out with 4 of these, leaving me with 2. So I've really just got the square root of x squared over the square root of 2. And I know the square root of x squared is x over the square root of 2. So then I just need to multiply top and bottom by the radical in the denominator, square root of 2, which makes it, you could say x squared root of 2, you could say square root of 2, x as square root of 2 is coefficient. It doesn't really matter. I usually would just write, I actually would probably write the square root of 2 first, just because it's the coefficient. But then I would be afraid of accidentally putting the x underneath, so it's just, however you see, it's fine. Okay. Number 14. So number 14, again, I want to simplify vertically. So I see 12 and 18, and I notice they're both, now you might be like, okay, they divide by 3, but then you might notice that they divide by 2 as well. So after you're done dividing by 3, I would look for the largest number that goes into both, and that is 6. 6 goes into 12 twice, and 6 goes into 18 3 times. And then I would cancel out the number of x's. So 2 of these cancel out with 2 of those, leave me with 3. 5 of these cancel out with 5 of these, leave me with 4. And 2 of these cancel out with 2 of these, leave me with 2. So you're really dealing with the square root of 2x cubed y to the 4th divided by the square root of 3z squared. You could go ahead and rationalize, multiply top and bottom by the square root of 3z squared, but if you notice that, if you notice that you can simplify in the numerator and denominator with the square root before you rationalize, you make your life a little bit easier. So I know that 2 goes, I can't take the square root of 2, but I know that 2 goes into 3 one time with 1 left over, so 2x. And then 2 goes into 4 twice with none left over, so I've really just got that. Divided by, don't need that. I know 2 goes into 2. 2 goes into 2 one time, so I've got a z, and then I've got the square root of 3 left over in the denominator. Ah! Okay, just threw that. Now, I want to rationalize. The only square root I have in the denominator is square root of 3. So I'm going to multiply top and bottom by square root of 3. And so what I get is x y squared times the square root of 6x, 2 times 3, and then divided by square root of 3 times square root of 3 is 3, so 3z. And that is my answer. Alright. Number 15. So number 15, the only number I have in there is a 6, so I'm going to leave that down in the denominator. But I can simplify my x's. I've got 1x here canceling out with 1x there, leaving me with 2 on the top. And then 4 of those cancel out with 4 of those, leaving me with 1 in the denominator. So I've got the square root of x squared divided by the square root of 6y. And I can simplify real quick. The square root of x squared is just x over the square root of 6y. And then I need to multiply to rationalize, so I'm going to multiply by the square root of 6y. and that is x squared roots of 6y divided by the square root of 6y times the square root of 6y is the square root of 6y squared, which is just 6y. And so there's my answer. Number 16. On number 16, I want to simplify first. Not all of them, I want to simplify first. So I've got negative 64 divided by 8. Okay. Negative 64 divided by 8. Well, negative 64 divided by 8 is a negative 8. Okay. X's, I've got 6 of these, with 6 of those leave me with 1. 4 of these, with 4 of these leave me with 3. And then 3 of these, with 3 of these leave me with 3. So I've really got the cubed root of negative 8xz cubed divided by the cubed root of y cubed, which makes it really easy. Okay, so the cubed root of negative 8, well, the cubed root of 8 is 2, so the cubed root of negative 8 is negative 2. Remember, the odd root of an odd number, the odd root of a negative number is negative. So I've got negative 2. There is not a cubed root of x, but 3 goes into 3 one time, so that's negative 2z times the cubed root of x, and that's just it in the numerator. And the cubed root of y cubed is just y, and there's my answer. Simplifying vertically will make your life so much easier if you do that first. On 17, let's see. So 17, 32, and 10, they both divide by 2. So I'm going to write that as 16 and write that as 5. 5 of these cancel out with 5 of those, leave me with 2. 7 of these cancel out with 7 of these, leave me with 2. And 8 of these cancel out with 8 of these, leave me with 7. So I've got the cubed root of 16y squared divided by the cubed root of 5x squared z to the 7th. Alright, so this is one of those times where simplifying in the numerator and denominator first before you rationalize will make it easier. I know that 16 is 8 times 2. And I'm taking the cubed root, so the cubed root of 8 is 2, so I'm going to bring a 2 on the outside. And, well, I'm going to write it down here. There is not a cubed root of 2, so I'm going to leave that inside. And in fact, I can't do anything with that y squared either, because 3 does not go into 2. So I've got in the numerator 2 times the cubed root of 2y squared divided by. There's not a cubed root of 5, so that stays inside. 3 does not go into 2, so that stays inside. But 3 does go into 7 twice. So z squared. And I'm left with a 5x squared. 3 times 2 is 6 with 1 left over. Alright, so we need to rationalize. Well, I have a cubed root. And in the same way that the square root of x squared is x, the cubed root of x cubed is x, which means in order to simplify out a root or to rationalize a cubed root, I need 3 cubed roots, which means I need 2 more. So I'm going to multiply by the cubed root of 5x squared z twice. 5x squared z. So I've got the cubed root of 5x squared z times the cubed root of 5x squared z. So my numerator simplifies to this. I've got 2 on the outside, and then I've got a cubed root of, and I'm going to multiply it all together. 2 times 5, which is 50. I've got 2x squared, so that's x to the 4th. I've got y squared, and then I've got z times z, which is z squared. So far that's my numerator. And then my denominator, I've got all of this, which is 5x squared z. It's the cubed root of 5x squared z cubed, which is just 5x squared z times z squared, which is 5x squared z cubed, because z squared times z. Okay. There's actually one more thing I can do to simplify. 50, the cubed root of 50 does not simplify as far as like, always think about like dealing with that number. It was a 5 times a 5 times a 2. These are all prime, and none of them have like, this is 5 squared at most, and 3 doesn't go into 2, so I don't have to worry about that. But I do see that I have a power larger than, if it's equal to or larger than the root, then you can simplify it. 3 goes into 4 one time with 1 left over. But then I have an x on the exterior in both the numerator and denominator, which means I can simplify. So one of these cancels out with one of those, making my final answer 2 times the cubed root of 50x y squared z squared divided by 5x z cubed. And I think there actually are there 2 more rationalization problems. No, that's it. Okay, so that's going to be page 1, and then I'll start the next video.